And hello once again, welcome back to Harry's Jeti Clinic. In this one we're going to look at setting sequencers. What do you want sequencers for? Well, there's things like retracting undercarriage and their doors have to move in sequence. You might have a power pylon in your glider on the fuselage behind the cockpit where the doors will open and this pylon will rotate upwards, and then you can run the motor, and then the pylon has to go away and then the doors would close. You might, if you're into boats for instance, have a battleship and you'd like to, let's say, a turret just to cycle backwards and forwards on its own. That can be done in sequencing. You can just switch it on and off and leave it to its own devices without you having to stand there rotating the knob backwards and forwards. Or maybe if you've got a model aircraft with a gun turret and you've managed to squeeze a servo in and you'd like to rotate it round, it'd be nice in flight if you could just flick a switch and it just sits there cycling backwards and forwards and doing its thing without you having to manually control it. But the main one is going to be for retracts and doors. So let's have a look at that. We're going to deal in this video with the simplest type, where the door simply opens and stays open when the wheels are down, and the door does not close until the wheels are up. And I think that'll take up all the sensible time in this video, so I will then be doing a subsequent video where we create the type of door that the P-51 Mustang or the F-86 Sabre has, where on selecting wheels down, the doors open, the legs come down, and the doors close again. And if you want, we can even look at something like a Starfighter, which I have, where the main doors over the legs and in the nose leg, they just open and stay open, but the doors over the wheels have to open and close again. So you can cope with all of this in the system. Let's take a look. I've already created a model. I went into model, new model, and I created a very basic model, and in the option how many gear servos does it have, and it's a sort of slang term, gear for retracts, I chose 1. So if we look in the basic properties of the model, it's in there. Came down here, I said I've got 1 gear servo. Notice there isn't an option for a door or any more than 1 gear servo. Doesn't matter, we can set all this up ourselves. So what we do is we go into functions assignment, and there is the gear. And what we want to do, and this is going to sound bizarre, is get rid of the control. The transmitter has automatically assigned switch H for it. I'm going to clear that out completely, and I'm not going to assign a control. And the reason for this is that we assign the control in the sequencer. Okay? We need doors as well. So plus, new function, door. Say OK. And once again, I'm not going to assign a control for it. The sequencer will handle all of this. So if the sequencer is going to do the retracts or gear and doors for us, why have I created functions when they may not really be necessary? Because the sequencer will also handle the travel values. So I don't necessarily even need a servo created for it, because I won't need to use the max travel values and centering in the servo setup menus. Well, the reason for it really is in the next screen. It means that in servo assignment, I can set one that I will call gear and one that I will call door. And you would actually assign as many of these as you need for the number of valves that you have in your aircraft. And once again, you're saying, why have I done this when you're telling me that everything is handled in the sequencer? Because in the sequencer, it asks you, what channel do you want to overwrite? And I would just say, oh, for the gear sequence, overwrite channel 6. And in the door sequence, overwrite channel 7. Now, if I'd left these as blank, nothing would go in there, even though those channels were being used by the sequencer to operate the valves. And at some future point, I think to myself, oh, I fitted landing lights to this model. Let's find an empty channel to plug in the light controller. Oh, look in here, channel 6 is empty. I'll plug my lights in there. And all of a sudden, your wheels don't come up when you take off. You know, you take off, you flick the wheels up, and the doors close, but the wheels haven't gone up, and you're in trouble. You know, what? Why? So the reason for it is you put that in there simply to, in effect, tell yourself those channels are used. And the reason I had to create functions was because the function allows me to allocate the name to it. I could simply have assigned gear 1 to that as well. At least in the future I would know that it was taken up. But by knowing it's the door, you know, when I come to actually plug things in the model, I've got the door valve, and I think, well, ooh, where do I plug it in? It's much easier to look in servo assignment and see, it was number 7, than to head off into the sequencer and try and drill down to that sequencer and look in its advanced properties and see which switch was assigned. Okay, so that's why I am doing it this way. Press OK. Now that's done. Off we go down to advanced properties, and down here is a sequencer. Lovely. Now you have several sequencers, and they're labeled Q1, Q2, etc. I don't know why. These up and down arrow here allow you to move down the different sequencers. So if I press down to Q2, now I can move up as well because we're down at Q2, 3, 4, 5, and 6. So come back up to Q1. And let's say that I'm going to make sequencer 1 the retracts, or the gear, and Q2 will be the doors. Okay, so I shall press the programming dial and I will assign a switch. And my retract switch is that one down there. So I'll flick it up, and I've got it the wrong way around in effect, so I will reverse it there so that that's the up, that's the down position. Say OK. And the reason I've particularly wanted it this way around is in writing the sequencing. There's the switch, off, on. When the switch goes on, the sequencing will run along the graph that you've drawn from left to right. So when you switch on, it will go along whatever shape or curve you've drawn from left to right. When you switch off, it will go from right to left. So just to try and help keep things clear in my mind, I'm going to say that the sequencing is gear down, gear up. Okay? Now, oops, come out of that one. I shouldn't have pressed the button again. Just confirm I've still got it. Good. Escape from there. And if we come down to advanced, we can give it a label. So it will be gear. I prefer the word retract, but gear is shorter to put in. Okay. And we'll overwrite channel. Do you remember? It was channel 6. Why gear is in 5? I don't know. Did I? When we created a model, it automatically assigned channel 5 to the gear, but I said I wanted it in 6 and 7. You can go back into the servo assignments and change channel 5 to something else. Anyway, we're using gear channel 6. The type of path will be symmetrical. We'll come to these later on if you need to. Say OK to that. And now we know that sequencer 1 is the gear. And we've set our switch for it. So now we're going to actually draw the curve that we want. Now you're probably thinking, I just want the legs to come down and I just want them to go up. But think about it. When you switch the gear down, you want the gear to wait, say, half a second so that the doors can open, and then the gear to come down. And when you switch up, you don't want the gear to come up straight away, or do you? Yes, you want the gear to come up straight away, and then the doors can close behind them. So you do actually want a little bit of delay on selecting down. There's no need for a delay on selecting up because you want the legs out the way fast and then the doors can do their thing. So we come along to time. Time, 0 seconds. And you'll notice you can do this in tenths of a second. There's 0 second, 1 second, 2 seconds, 3 seconds. And we're going to draw a nice graph of how we want our thing to go. And so we say at time 0 seconds, we're going to add a point. So at time 0 seconds, this very fine dotted line is a sort of 0% travel. So that's servo at midpoint. So it will come along to the value, and I'll say that it needed actually to be at 100% of travel. Notice this is where you can set the actual servo travel. See that point's coming closer back to the midpoint at 0, or I can go negative and drive the servo or valve the other way. But let's just say, to make things nice and obvious when we look at the servos later actually doing their thing, I'll just set it to 100% travel. That's fine. Use 100%, minus 100% if you've got electronic valves. If you're using servo-operated valves, this is where you can adjust the actual travel value to exactly match the travel you need in the valve. Okay, now I said we wanted to give it, when we select down, we want to give the legs half a second to let the doors come open. So we go into the time, move, as you can see the bar is moving along to half a second, and I want to create a new point. The value will still be plus 100 because we don't want the servo to move in that half second. Okay, lovely. Now let's keep moving, and 0.7 of a second, or just even 0.6 of a second later, we create another new point, and its value is going to be minus 100, the other end. So this is what will happen. When we switch down, the valve or servo will be at plus 100, and it will stay at plus 100 for half a second, and then in the next tenth of a second it'll drop to minus 100, in other words the other end of its travel, and then stay there. Okie doke. So we're okay with that one. Come over to there. And that's it. So that's set the legs. Let's operate the switch now. When we operate the switch down, it will dump there. And can you see this very faint vertical bar? Remember, when I switch off, it will go from right to left. So boom, immediately the wheels will come up and it just stays up. But on selecting down, there's a half second pause and then bang. Okay, let's have a look at what that's doing in the model, just to prove it. If we plug in, this had better work. Yep, so there's the retract servo. I'm switching up now, I'm switching down now. So up, down. See, there's that little pause on switching down just to give the doors a chance to open. But on switching up, switching up, they came up straight away. Okay, now let's just switch that off for a moment. Let's
Signal
look.
lost.
Yes, dear.
Signal lost. Signal lost.
Oh, well, easiest
Signal
way to
lost.
shut her up. I'll plug it back in.
Signal lost.
Now we'll come down to Q2, which will be the door sequence. So press the down arrow, go into Q2, lovely. The switch is going to be the same retract switch, so I'll put it in the off position, go into switches, do that, that's its on position, Okay, so now Q1 and Q2 are both assigned to the same switch with off when the switch is up and on when the switch is down. So the sequencers are running the same way. You don't have to, but you'll have to draw your sequencer in reverse, this kind of thing. And we'll come down to advanced and we'll give it a label. We'll call it door. Say OK to that. And it will overwrite channel 7, which handily is named door. Remember, if it's got a name door because we assigned channel 7 to door in the servo assignment, and the option to assign a servo to the name door was only there because we'd created a function in function assignment, even though we hadn't given it a control. Okie doke. Okie doke. So we're in the door sequence, which we know because we've got the box around it. Come back up to the switches. Let's move along and program its curve. Remember, from left to right is what's going to happen when the switch is pushed down. So down condition will go from doors closed to doors open pretty much instantly. But when coming back up, we want there to be a delay and then switch up. So at time 0, press a plus, give it a value, and the value will be, remember if you're going to switch down, it starts off in the up position, and for the sake of this demonstration, we'll call that plus 100. Yep, there's the little dot above the 0% line. Okay, and then we'll scroll along to time 0.1 second, create a new point, but this time, stay at point there. Now we want the value to be minus 100. So in the first 0.1 of a second, the servo or valve, electronic valve, will be given the command to open. Yeah, good. And the door is open. You wanted the door to stay open. You think, well, that's the end of programming. Well, not quite, because remember, when we select up and the sequence goes from right to left on the graph, we want there to be a delay. If we left it like this, the doors would just close straight away. How long do we want to give the doors staying down before we let them close? Let's say we'll give it up to 2 seconds. So we'll dial along to 2 seconds. Plus, it's still keeping the value minus 100 for us, so we're happy with that. That's it. So if I put the switch is in the up position at the moment, I'll put it down, back to the up. Okay. Now then, the switch is up, which means everything's over at the left-hand side. When I switch the switch to down, which goes to plus, all my sequencers will run from left to right. So you can see what's going to happen here. Immediately, the doors are going to open. There'll be a half-second delay, the legs come down, and the doors will just stay open. But when I switch up, the sequencer will start over here, and it'll hold the doors open, but the gear sequencer will start here. It won't start over here. See, the door sequencer starts at this point, but the gear sequencer will start at this point, its point, last point. So immediately the wheels will come up, but the doors will still be trundling through there a bit. So switch down, there we go, and switch up. Let's have a look at it in reality. You are. There's our gear, there's our doors. The wheels are up. I'm going to switch wheels down. So the door should open immediately, and there'll be a tiny delay then, and the wheels will come down. There we go. Now I'm going to switch wheels up. Wheels should come up straight away, but the door should wait until the end of 2 seconds before it closes. There we are. And that is how to create a basic sequencer. And we'll look at more advanced sequencing in the next video.